Hello, this is James from XRobots.co.uk. This is part 2 of my mobile robot navigation project using the 914 PC bot, which you can see just down there, with an Xbox Kinect on top. So this is the robot that I showed you in the last video, which is a small mobile robot on wheels. At the moment the Kinect is looking down the hallway. The brown thing you can see in front of my XRobots sign is a cardboard tube. And if we take a closer look at the screen here, I'm using a piece of software called RoboRealm, which is displaying a depth image. That's not the best shot on the camera, but regardless, you can see pink things in the distance are further away, and blue darker things towards you are closer, and we can make some adjustments to that. And we can have different colour schemes and so on. So one of the things I've been thinking about is how exactly do I interpret this data to navigate with the robot. Obviously Kinect is quite powerful because we've got a depth camera with various settings. So RoboRealm has a line function built into it, and if I do this you can just see a line on the screen. So if I'm to move that cardboard roll closer, and we should hopefully be able to see it represented by the line. So we can see the edge of the cardboard and we can see the bottom of it. So I had this great plan that that'd be really easy, and using RoboRealm's processing functions we can sort of fill in some of it. There's lots and lots of functions in RoboRealm for image processing, and we can get rid of any sort of errors that are in there due to shadows and so on. That's using the erode function. We can smooth everything out using the smooth function, and the last one is a point location. The intention being, I don't know if you can see that red dot, the intention being that that would tell the robot which way to go. So basically that's looking at the highest point. So that would tell the robot to travel to the left slightly, and you can immediately see the problem there, that with an obstacle in the way it doesn't know which way to go. The other issue is once the obstacle gets too close, then this happens. And if we look back to the laser line, the line shoots straight to the top, and that's because basically the object is out of range, it's too close. So in fact that's not the correct image. If we come back again and I push the robot forward, things all go bad and the picture breaks up, and that's because we're within the minimum range of the Kinect. So at that point the laser line goes wrong and shoots to the top, and then obviously my processing's broken because it immediately thinks something's really far away. So if I were to take that object away, well, that's not terribly good either. The idea is that it's supposed to simulate the laser line from a laser scanner, which would typically give you a, you can see the wall there, and then you should get a much higher line going down the corridor and back again, and that's the wall on the right. So it's what you should get from a commercial laser scanner, which costs several £1,000s. But obviously with the Kinect having a minimum range, that doesn't seem to work too well. So I had to think about, how to process the data differently. So back to the depth colour image, which we can see with pink in the very distance and darker objects coming closer. There is actually more contrast than you can see here on the actual screen. I've put a couple of cardboard tubes down, a cardboard box down the hallway, which you can then see represented on the image there. So there's, as I say, lots and lots of functions in RoboRealm. If you look at roborealm.com, there's a lot of documentation for each one. Literally probably over 100 different image processing functions, and all of them you can pull the variables out using the API to write your own code. You can also write VB script within RoboRealm, and you can control specific pieces of hardware which are supported by RoboRealm. Obviously if you write your own code using the API, you can control any other device such as this robot. So one of the functions I've used next is colour depth. So I've basically reduced to 64 colours. I could reduce it further to 32 or as granular as I want. So the original image obviously fades from pink through to blue. I've reduced that to 64 colours, so hopefully you can see some clearer steps now, and you can see that the box, which is closer in real life, is darker than the tube, which is further away, and then right at the back we've got pink, which is the furthest away distance. So that's given me some more granularity. The next thing I've done is to sort of separate those regions out using blob separate, which puts a nice border around, and that then means you can use some image processing algorithms to track these individual areas. So now we've got, what's that, 1, 2, 3, 4 depths. I've smoothed that off with the smooth hull, so it's nice and round and there's not too many sort of separate sections. Sometimes you get the odd one that pops in. Like there we can see there's lots and lots of blobs, and smoothing it out gets rid of it to some extent. And then I've used blob filter to track the blobs. So this is quite a good function where you can match by colour, darkest, brightest, a specific colour match, proximity to the top or bottom of the image, as well as location, the size of them if they're over a certain pixel size, and basically we can assign a weight to every blob by ticking this box. And all of this data is presented through the API. So what we've got here, if I zoom right in, hopefully you can see a rather granular image of my hallway and the objects in it. And you can also see a number, so basically 1 or close to 1 is the darkest of the image, going all the way back to 0.43, which is the furthest away thing. So obviously that's quite segmented. If I go back to the colour depth and change that for some more, then we get even more granularity, and we get a number on each blob. So basically what this gives us, there we go, there's an extreme version. What this gives us, of course, let's go back to 32 colours. Quite a simple view. I've sort of settled on 64 colours. Otherwise there'll be too much data to process. But what that basically gives us, of course, is a point cloud. So we can get the dimensions x, y of these centres of gravity, which is the centre of the blob, and we can get the numbers. So we can basically do a 3D point cloud. So we can effectively build our own very simple 3D image that we can access with a Python script or something, so we can roughly work out what's going on. So obviously here we've got a bit of an issue, which is the floor and the walls are all joined together, and that's something I need to experiment with, but we can tip the Kinect up with its motor. So don't know if you saw that. Let me just do it again. So you can control the setting. RoboRealm lets you control lots of other things as well, like the LED colour, and also you can read the accelerometers that are inside the Kinect, so which is quite useful for some applications. Anyway, so if we tilt the Kinect so we can't see the floor so much, we can see it a bit there, which is inevitable as we look forward into perspective. But anyway, now we can see where the walls are clearly, and we've got 2 blobs and effectively a target. So as I move the robot around, you know, we can see the blobs, and we can, if we're comparing the robot with a map of the environment, so if I had a known map of my hallway, then we could obviously point it so that we can head for the lowest number, and that should be the end of the hallway, and we can avoid the obstacles, which are the higher numbers, and obviously we can avoid these things as well. So if I go and take those objects away, we should see, as well as myself, you should see quite a clear image of the hallway which we can use to navigate. So it's going to spend some time crawling around the floor, pushing this robot around, and we can see what we can see using this method, and whether there's any errors. So what's happening here at the moment is, of course, I've got the Kinect on the front of my PC bot. My laptop's resting on top. Everything's actually powered by the mains at the moment. So there's two types of Kinect. One has a USB port, and it takes 2 amps at 5 volts to power it. This particular one is in fact a 12 volt one, which has a special type of plug that then plugs into a mains adapter, and then the power goes in one side and USB comes out the other side. So that's not bad on the whole, because the robot's actually got a 12 volt battery and regulated power supply on board. So I've got another one of these power supplies, and the plan is to just cut the cable which would go to the mains adapter providing 12 volts and wire that to the 12 volt battery to power the Kinect, and that way it won't run the batteries flat of my laptop, which is going to ride on top, powered by its own battery. Hopefully this mains lead's long enough I can just give this a push. Obviously we can see the pink's disappeared already, and as we head down the hallway things get bluer. Hopefully you can just about see the number there, which should be getting higher as we get to the, or at least the colours are getting darker. We've got a 0.71, and eventually, as we get to the end of the hallway, darker again, 0.81, darker again, and we've got some black areas appearing which previously messed up our laser line, and we should find as soon as we get lots of black starting to appear. So pretty much when there's black it means there's an obstacle. We're really close to the wall. So as we go around the corner here, obviously we can see the banisters in their glorious detail, and then we get pink again in the distance. We can probably just make out that doorway into the toilet, and that's all very well and good by the looks of it. Obviously the next issue is the drop for the stairs, and the Kinect isn't going to see that, but unfortunately the PC bot has these infrared sensors as well, which act as drop sensors facing down, as well as the skirt sensors, which we can use in conjunction with the Kinect data to double check what's going on. So that's all I have for this time. Check out my website xrobots.co.uk for more information on this PC bot and other videos and projects.